A very welcome to everyone. Today I'm going to talk about business continuity and disaster recovery in Azure. This is commonly known as BC and DR. But before we dive deeper into this two major aspects, I want to highlight a bit more on the basics of Azure. So how Microsoft runs this world-class cloud service and what do we really mean by resiliency. So if I read out the documentation here provided by Microsoft, the definition for resiliency says that it is the ability of a system to recover from failures and continue to function. It is not just about avoiding failures, but responding to failures in a way that avoids downtime or data loss. The goal of resiliency is to avoid failures, and if they still occur, return the application to a fully functioning state following an occurrence. The faults can be various levels, and it is important to have protection based on your application availability requirements. So that is important. So failure can happen and will happen. So how we prepare ourselves when that thing happens. So what is the expected data loss and the downtime of the application which is allowed for the business? There could be application which doesn't really tolerate any data loss. For example, if it is a financial transaction, no data loss is allowed, right? But in certain scenarios, data loss is okay, depending on the importance of that application, right? So it is up to the business to decide, and we have certain goals we need to set to be able to do that. We'll discuss that in a moment. Now, to understand the Azure Foundation, as Azure provides a cloud scale service mostly managed by Microsoft, we have something called SLA, right? And what does that mean is a service level agreement. Unlike the software which you purchase and install in your own operating system and in your own on-premises data center, you own the responsibility of maintaining and managing the server. If the software is having a bug, then you raise a ticket with the corresponding vendor and then they provide you the support. So that's a different model. This is a service provided to you in the cloud. Then mostly they are being controlled by a service level agreement, which essentially says that how long this service can go offline, and that's a guarantee you get. So anything beyond that, then you have to read out the service agreement to understand what is the action to be taken. In terms of Azure, we have got 5.9, that is 99.999% SLA across the fleet. So that's the trending of Azure today. And also Azure has got certain way to handle things. For example, when you talk about the traffic between two Azure services, they always use the Microsoft internal network that is not exposed to public. We have laid out where across the Pacific, across different continents, and all the Azure data centers are connected using those cables. So they are very private, very secure in terms of their data when it is traveling. And also in terms of detection, right? The failure will happen and we may be observing, let's say, the health of a server. So if a server is going to go down in 5 hours, how do you know that it's going to go down in 5 years? There are many different health probes, the events, maybe a failure could be an issue with the storage availability, right? So that server starts responding to those events. We capture all the telemetry within Azure to be able to, let's say, read that data and store it and then run some AI-based detection to figure out that potentially this block of servers or this rack can go down in few hours time. So we immediately take an action and move all the workload into another thing before that rack really goes down and you see a downtime. So it's a called live migration, which happens constantly within Azure as part of the management exercise, right? So it is all not sometime we need to wait till that thing to happen. We can easily identify based on our AI based algorithm, observing the logs coming from various different resources. Now that is key critical component. Now, as I said that we own the data center, we provide you the service, so hence we are responsible for making it available to you. However, it is a shared responsibility. So when I say it is a shared responsibility, I mean to say that depending on what kind of, let's say, services you run on where, you have also certain level of responsibilities. For example, when you take a look at this picture, if you look far towards the right hand side of the picture, where we talk about software as a service, it talks about everything owned by the vendor. So the blue color is owned by the vendor. So you can see that starting from application, data, runtime, middleware, operating system, and all other things behind the scene like virtualization, server, storage, networking remains constant for all different offerings, but the ownership, the responsibility is fully on vendor. That's why more and more companies are moving towards software as a service model to be able to get rid of this headache of maintaining, managing this business continuity and disaster recovery, because they pay for that assurance, right? So that's a kind of model which is becoming very, very popular in last 1 decade or so. Now, coming to platform as a service, it gives you an ability to write your own application the way you want to write and store the data the way you want to store the data. So you need more power over what SaaS offers. So you go ahead and build an application, and application definitely is with data. So you own those two, only those two pieces, right? Rest all things are managed by the vendor. And so in this case, if it is Azure, so and if you host your application in web app or API in the website, so you will not be able to, let's say, log into the server, install the runtime. So it'll be all provided to you as a full-fledged service. That's what we call as platform as a service. Same thing happens with Azure SQL database. It's a platform as a service database. So you own the data and you have an application connecting to that data, but inline infrastructure, the database, the availability of the data, the backing of your data, creating redundant copies just in case one server goes down, it'll be served by other servers, are all handled by Microsoft Azure for you. Now, for infrastructure service, you control also the server, because you may need to log into that server, remote into that machine as a remote desktop or SSH, and then configure certain things like maybe install a package solution, or you purchase a third-party software which needs an installation. Maybe it's a thick client application, maybe it's something very special which needs a dedicated virtual machine. So in those cases, you will go with this infrastructure service because you will need more control up to the operating system level, right? So you get an operating system and then you control everything from there. So that's how the responsibility will increase as you go from right to left, and on premises is everything on you. So either you or you're assigned a team of people managing everything for you. So this is what the conventional data center looks like, and that is why people are moving away from conventional data center, mainly because of the management overhead. So you need to focus more towards the business. Now, we talked about SLA briefly in 2 slides back, but this is where it basically translates to. So if you look into this picture, right, so there are various different 99% are available. So one of them says that if it is only 99%, it is a downtime for about 1.68 hours in a week. Now, this is the maximum downtime provided. Doesn't mean that it'll be having downtime of 1.16 hours. It can have no downtime for that week. So it can have, let's say, 0 downtime. In those cases, you are basically gaining. If it is more than that, then depending on the cloud vendor, you get certain benefits, or discussion can start having that why this is downtime is more than the downtime you promised. So that's how you basically are getting contracted with the vendor to ensure that services will run as expected. So like your electricity at home or telephone at home, you need to make sure that they work, because you don't control how the towers are being set up, how the grids are being established. If there is a natural disaster, what happens if the wire gets cut, right? So all these things are part of this service, any service you consider today. Now, as you can see, you can also find a public documentation about like what is around that. And that's a standard definition, right? So if what is 99.999%, which is an overall Azure SLA over a period of time captured by the Azure team, means that it's a downtime of 6 seconds in a week, right? But in certain scenarios, some server should not go down for 6 seconds. So you have those things. So now how do you handle, right? Even if you take the maximum 5 nines downtime, how do you handle that is something which has to be part of the architecture we need to discuss today, right? So we have to have certain services coming into picture to build the application architecture. And how do you handle that? So we'll basically be composing multiple SLAs together. So if you consider a simple web application, we are hosting a website in web app or app services, and then you have a database like Azure SQL database. These two provides you two different SLAs. Assume that you have two services, and one giving 99.95% SLA, another is giving 99.99% SLA. So how do you tell that end user that this is my composite SLA? So the calculation is simple. You just multiply all the SLA and you come up with some figure, and you put a decimal value after 2 digits, and that's your SLA. So in this case, it comes around 99.95. So it is not an average of 2 SLA. So that's how the composite SLA gets calculated. So this is something which will come back again and again when you basically have to define the SLA for your application. Now, when application decides to, let's say, use the downtime, allowed downtime, right? They have certain things like RTO and RPO, and these are very commonly used in industry. RTO is the maximum acceptable time that an application can be unavailable after an incident. So, right, let's say if your application needs an hour to make itself available, so let's put RTO as 60 minutes. So depending on that, you have the flexibility to either decide create an active replication or active passive replication, so that if one goes down, you spin up or you wake up the other replicated version. Or even in certain scenarios, if the RTO is too long, then you can actually run a DevOps pipeline to redeploy the application in a different location altogether, because you have that flexibility to do that. So depending on how your business demands, you will decide how that application availability would look like when things go wrong. Then recovery time point objective, or RPO, is the maximum duration of data loss. So it is all about data loss, which is acceptable. So in this case, like certain application which says that you have to have no data loss, so you create multiple database replicas across the geography. If one goes down, at least all the data are synchronized. You can point to another database and start working on it. So data sometimes is so important that businesses don't allow any data loss, right? So you will find certain scenario that RTO could be 60 minutes, 90 minutes, but there is zero data loss allowed, right? So depending on those kind of situation, you will be acting based on the business decision. MTTR and MTBF are the two things also to be considered in the DR and BC scenario. MTTR stands for mean time recovery. It is the average time that it takes to restore component after the failure. So unlike recovery time objective, which is straight away the time, it's the average time, right? And then you have that mean time between failures is something like, you consider that you have constant failure happening due to various different region, right? So it could be a data center outage, it could be an application bug, it could be anything. So you basically calculate based on the matrix provided, and then how frequently a service is becoming unavailable, what was the last time when it was unavailable, right? So an unavailable component that has the low MTBF will result a low SLA number, right? Which means that you have more frequent failures happening quite regularly. So how do you want to mitigate that? So that's also something which can be observed and get decided during the period of a lifetime of an application. So maybe initial 3 months or 6 months you observe that, right? So that's what MTBF. So you might find these things used in your kind of scenario. Now there is another important thing is to understand the failure mode analysis. So what it basically says that during the design phase, you should perform a failure mode analysis. What it essentially means is the goal of it to identify the possible points of failure. So you may be using 2-3 services. Let's say you have a database, you have a virtual machine. So a virtual machine can go in a reboot state if there is an important update happening. If your organization is pushing the security update which requires a server to be rebooted, right? So that's a possible point for failure, because while it is rebooting, your application is not available with a single VM deployment, right? So now when that reboot happens, how that application will respond to these failures. Now, depending on your application's resiliency and availability requirement, right, you can design a response strategy for various types of failure. Now, when I talk about types of failure, you can think of like, how will the application detect this type of failure, right? So maybe I'm interacting with a database, that database is not responding, so that's a failure. How the application will respond to this type of failure. So if we have, let's say, an application deployed into VM, and then we have a load balancer created, right? That's a part of application design. Then if one goes down, another is still serving the purpose. So the traffic will be redirected to the new application. So that could be one thing. How will you log monitor for these type of applications? So when things go wrong, so how do you do that? Now the FMA should be part of the architecture. So when you build the architecture, this should be under consideration. It cannot be brought into a later point in time. It's very difficult to do that. So it should be in design phases, right? So that you know that these are the possible failure, and that's how I will respond to it. So FMA is super critical for any application architecture design, right? So now the types of failure. So I talked about briefly about type of failure in the FMA, but if you talk about types of failure, there could be hardware failure, data center failure, regional failure, transient failure, heavy load, dependency service failure, accidental data deletion or corruption, application deployment failure. So as the name suggests, right, they are quite self-explanatory that these are the typical reason how your failure could be identified, right? So these are the types of failure. Now, in terms of cloud, hardware failure, you really do not have any control because you don't provide the hardware, neither you control the hardware. A data center failure is something which you also don't control. So it's the responsibility of the cloud provider who provides the assurance that when the data center goes down due to some natural disaster, maybe a cyclone, hurricane, or a lightning, anything of that sort. And when I'm giving these examples, I'm actually referring to historical event that actually has happened. It could be a regional failure. Let's say a pipeline gets cut. The network cable got cut, right? If the data center is alive, but because there's no network cable supplied, it's not responding anymore. Transient failure, sometimes it is dropped and then sometimes it is working. So how do you apply, let's say, retry policies into that? when your application has too much of a load, a lot of people interacting with the application, you basically have that heavy load issue. So your users who are coming late may be not able to log into this application anymore because it has reached its maximum capacity. So all these things are kind of like things. So dependency service. So for example, my application is built in such a way that relies on a logic app. That logic app is down because of some reasons. Hence my whole application garland, which I have created, connecting like a chain of call, is dropping at the logic app level. How do you handle that? Right? So what happens when you have those kind of situation? Even if your application is perfect, it is perfect, but one small component is not working. How do you remediate that is also something which is a case-to-case basis. So it is absolutely important when we design this, we bring in to our agenda that we have to have that remediation also in place. So when you talk about remediation, right? So there are various different things which you can consider. So some points I wanted to highlight, but there are beyond that many things which you can also consider. But let's talk about few things how we can create a remediation policy. For the hardware kind of failure, if you refer back to the previous slide where we talked about hardware failure, that's the first point. You can consider having a redundancy in plan. So if you deploy everything into one VM and that VM is down because, let's say, when I say hardware failure, it's not a planned maintenance downtime. It is basically unplanned when things go wrong. So you can have two virtual machines, right? Either active or active passive, and then your application will be landing into a load balancer pointing to the healthier VM, or maybe a round robin, whichever protocol you select, right? Algorithm you select for the load balancer, and then it will be providing the resources. So if, let's say, the VM A goes down, the VM B is still active, alive, and your traffic will be served and the data are saved because data is stored outside of the VM. So all these things are the kind of remediation exercise we typically do. Replicating data and components, that means you have that, especially for the business critical application where things cannot go wrong, you create a replica, right? So always ready to serve. So when things go wrong, you immediately switch over to the other deployment so that they can start solving, and the data is always replicated while the application is being used in other region. The secondary region will have the updated data because that's what user is really worried about, right? And then you have got retry transient failure, which means that if you keep trying, let's say if you fail to connect to a SQL database, but if you just drop there because it couldn't connect, that may not be the good application design, I must say. So Azure provides all the REST API within Azure provides the retry policy built into that. So you enable that retry policy. So let's say I will retry for 5 times, 10 times. So you define that in the code of your application to keep retrying if, let's say, it fails. So it'll keep retrying, and after, let's say, 10 retry, 5 retries, it'll come back and say that, hey, I couldn't connect. But it will never come back after the first failure and tell you that I'm not able to connect to the SQL server. So that's what should be built into the system. Load balancing across instances, which means that I talked about VM while doing that. So degrading gracefully is if a service fails and there is no failover path, provide an acceptable user experience, right? So it means that, let's say I have a package solution and I only have one license available today. I deployed in a single VM kind of scenario. And if that VM is down because of any reason, should I give that experience back to my end user? So degrading gracefully, which means that there is no failover path, I cannot have another VM providing me, and all these things. Backing up the data is so important that it can be restored whenever there is a data loss. And also things like automating the deployment is key critical component, which I didn't mention here, but it basically says that when you have to, let's say, redeploy the whole thing, you should have a DevOps, 100% DevOps. No manual CLI going into remoting to the machine and writing the command prompt to configure anything, or going into the portal and doing things. Everything should be automated either through infrastructure as a code or by some automation exercises, right? Has to be in the pipeline so that a single click can do everything, or maybe some automation to trigger those activities can do everything, right? So that's what I wanted to highlight here. Now, there are certain built-in Azure solutions available in these kind of situations. I will not go very deep into everything, but think about like having an availability set. Availability set ensures that if you are creating redundant VM, they don't go down in a planned maintenance kind of scenario when patch update is happening at one given point in time. So at least one of them will be alive, even if they are in the same rack, same server, same data center. At least one of them will be available when there is a planned upgrade happening. That can easily be done while you configure the VM. So you predefine an availability set, you give that availability set name to all the VM, and that's how they are identified by the backend management for Azure, to making sure that at least one of them is alive during the planned maintenance. Availability zone ensures that even if the hardware data center failure happens within the same region, you have a let's say isolated zone available. So now availability zone is something which is not available in all Azure regions. So only certain regions supports availability zone. So when you are designing that availability zone, make sure that you check the availability zone availability in that Azure region. So that's important. Azure Load Balancer is something where you basically put things into multiple instances. Either it could be an application, website, or anything of that sort, and then you create Azure Load Balancer to load balance your traffic into the backend thing. Traffic Manager is across geographies, across subscription. You can actually have two different location where you have same application hosted. Let's say maybe you have customer from both Europe and US, and you have two deployment, one in Europe, one in US, and then your traffic lands into your traffic manager, and based on, let's say, performance, so the US users will get the US data center access, the Europe users will get the Europe data center access. So you choose the performance as your algorithm to redirect the traffic, you get into the closest data center. So you can have a round robin also, and then random also is possible. So you can just land anywhere as you are being allowed by the traffic manager. Azure Site Recovery is something which is built into the Azure as a service, which basically means that it creates the virtual machines in another Azure region for business continuity and disaster recovery. You can conduct a periodic disaster recovery drill to ensure that you meet compliance need. The VM will be replicated with specified setting in selected region, right? Those things are built in as a service. So if you use this service, you get the full flexibility of doing many things natively within Azure. Backup, absolutely important. So you must not miss taking the backup, whatever that reason may be, right? So it is important that you consider having the backup on a regular basis. And then in terms of, let's say, storage, which is also a key critical component for most of the Azure services we use, you can choose the storage depending on like what kind of replication you need. By default, storage gives you the locally redundant storage replication, which means that you create a file in Azure Storage, you get 3 copies of the file automatically, and we don't charge you. So if it is 1 MB file, you won't pay only for 1 MB. But actually there are 3 MB of the same file getting saved into 2 other places. Always 3 copies, right? So if one file is corrupted and that blocks or the node is not responding and cannot provide you that, you will be provided with the other copies. Zone redundant is something within the storage. If you have Azure availability zone, if the data center or the region is a zone ready, then you get a zone redundant storage, which means that copies will be in the zone instead of in the same, let's say, building. And then geo redundant is across geography. So generally we have paired data center. For example, If you consider, let's say, East Europe and West Europe, so these are the paired data centers. So if you put something in West Europe, it will be copied in East Europe, something like Singapore and Hong Kong, East US 1, East US 2, like that. So you have different data center copies, but typically they are within the same geopolitical boundary, which means that they follow all the data privacy, governance, etc., all these things, because it's all about data at the end of the day. And SQL also does provide a zero replication, so just in case you have to have a copy in other region, you can always choose to do that. Now, fault injection testing is something which is quite interesting, right? Which basically is a testability. So sometimes you design, you deploy, but what is the guarantee it will work? So you need to do the testing. So the fault injection testing is the test. It is to test the resiliency of the system during failures, either by triggering an actual failure or by simulating them. Here are some common issue things which you can consider. Like maybe you can go and shut down a VM instance. Just go to the portal, click on stop deallocated, or you log into the VM and then just manually shut down that. But how that then how your application reacts to it? Is your end user being bothered because that VM is down? Then it's not working. It's not failing over. You can crash. You can expire a certificate. If let's say the application is using some certificate, if you just forcefully expire the certificate or put an expired certificate, how that reacts to that. You can change the access keys. So we can, let's say, time to time change the access key to see if application is able to pick up the new access key. So what happens in those scenarios? So you're accessing a SQL Server username through username and password. You change that username and password, or you change the password. So how that application reacts to that? These are all external dependencies, right? So because maybe a DBA decides to reset all the password within that organization, what happens to your application? So those are the kind of things we can do in the fault injection testing, which are basically an intention to make sure that we are ready in those kind of actual situations. It may not happen. It may not happen that your database passwords are being changed by somebody else. But what if that happens, right? And I have seen that during my application development phases that sometime DBA decides to change the password on a fine morning. None of our applications are working because we were not informed by them properly, right? And how can unmount a disk, which can be done from a portal. And then if you unmount a disk, all the data belongs to that disk. What happens to the application? If you redeploy the VM, it loses all its configuration with internal configuration which you have done manually. How do you handle that? Is there DevOps is something which you should be considering to automate the new deployment, or you should be continuing with the manual. Manual you never should consider. That's not a point to discuss here. Now to testing the failures and response strategies, continuing that you have other two types of testing, like load testing. What happens when you have unpredictable loads? Let's say you designed your application for maximum 100 users at a time. What happens if, let's say, 200 user comes in at one given point in time? It can happen because you do not have a stoppage, right? So your business can significantly grow, especially for the consumer based application. Load cannot be predicted that way, but for internal application, you know that, hey, my business will have maximum 50 users, so I can afford to have an application with a capacity of 100 and still survive. But for public facing application, especially the consumer application, things may go in spike, and it's a good sign because you are doing more business. So you have to be ready with that thing. So disaster recovery drills is something you have to do on a regular basis, which Azure Site Recovery offers pretty natively. And DevOps is something which is key critical component, and I have discussed it in many different times in many different slides. Prior to this is your infrastructure as a code, IAC. Which means that either Terraform, ARM template, Bicep, CLI, PowerShell, whatever way you want to deploy your resources, use those methods rather than going into portal and clicking things manually. Create an immutable infrastructure, which means that you shouldn't modify the infrastructure after it is deployed. That's the whole idea. So if you deploy a VM, you should not get inside a VM and then do something. Okay, you create a state. So desire state configuration. Maybe you want to install or configure IIS within the VM after the VM is deployed. Do it through script. When the VM is done, pass the desired state configuration script as part of the VM creation process, and then it will automate that thing. You should not get inside that and use your mouse or keyboard to do all these things, right? That's not immutable experience. Rolling out. So when you have to, let's say, make changes, roll out new application. Rolling out can be different strategy. Like blue-green deployment is commonly known as blue-green deployment, which means that you have an application already running, live application, you make some changes, that's a version 2. You may redirect your 25% traffic to the new version, and then let's say when this 25% traffic are not complaining, they're actively fine, you eventually switch over to this 25% and make it 100% so that your application now is having only newer version. If the 25%, which is the new version, is giving trouble, you immediately switch back to the old. So you basically redirect your traffic. So that's a blue-green deployment. Canary releases are like blue-green deployments. Instead of switching traffic to an updated version, you roll out the update in small percentage of users. So it's basically like how you want to do that. So in the blue-green kind of scenario, what you can think of, like you have an application running somewhere, you create a slot in app services. In Azure, you switch that. In Canary, you basically have the percentage option. So either way, so depending on how you want to roll out is what you want to design and decide. So you basically have to discuss with your DevOps team to come up with a plan on how they want to handle it. How to monitor. So monitoring has to be part of your application architecture. Instrumentation like App Insights or anything of that sort, which can read out things from the code base, right? So how do you do that? And then you have that collection of the logs and then storing it somewhere for the further analytics, like collecting logs for application traces, IIS, performance counters, Windows or operating system logs, etc. We have many different things like log analytics to store mainly the logs coming in from various different resources. And then you can run analytics using Azure Custo queries. So it's like a SQL-like queries for those kind of log data. Azure Advisor also provides the recommendations. So Azure Advisor is something which is default available within Azure for you to use, and I recommend that you strongly consider that. Visualization of the alerts is also important. So when things go wrong, you get alert, and how do you visualize that? So you have that Azure dashboards, and then you have that Azure monitor alerts, which basically helps you create alerts on service health and resource health. So sometimes, let's say you have a deployment in data center 1, and that data center has a planned maintenance, and during a period of time a service may go down. So we will know it from the service health and resource health alerts, because these are the planned maintenance happening, and we can have alerts built into our system to notify the, let's say, ops team to know about there is something happening here. Maybe you want to notify your end user saying that, hey, there's a data center maintenance happening, or you move your workload into another location so that you are not impacted. So again, depending on RTO and RPO, you will be responding to those things. Now, again, responding to the failure, you can have alerts, failover, operational readiness testing, data consistency check, restoring from backup. So I've been taking many backups, and that's what I have seen in even many different architectural discussions, that people are concerned about the backup, but they're not really well planned in terms of how do they do with that backup when things go wrong, right? So that is important, right? When things go accidental deletion of corrupt or of a data, or a corruption of data, right? How do you revert back from the backups you have taken? So Azure Backup can restore Azure virtual machines quickly, but there are other kind of backups. What is the RTO, the data loss strategy here? So can you tolerate, let's say, X amount of data loss, etc. And then Azure Backup can also gain the point-in-time recovery for SQL Server and SAP HANA databases running on Azure virtual machines, providing RPO as low as few minutes. So those are the built-in capabilities you must explore when you're considering that thing. Now, in terms of your IT infrastructure, you may be responsible for your application because the platform is centrally managed. In situations like when you don't really need to worry about the network being laid out for you, or the storage or the core compute services provided by your organization to deploy your application, it's not your responsibility. It's the organization's IT responsibility, central IT's responsibility to handle that. So you need to create some sort of RASI to identify like who owns what piece and focus only on that rather than focusing on everything. So if it is only application and the data like I talked about in the past, so you focus only on that. You really don't need to know or put any thought around how the operating system are being patched, how the run times are being maintained, how the hardware failure is being controlled, because it's not your part of the story, right? So it's good to know that you don't own it and then explicitly call it out, and then also put a support channel available. What if that happens? When hardware goes down, how do you react to it? Is something you need to do that. And then you have this key services which you typically would be using for your application, where you need to consider having a backup. So with this, thank you very much and have a great day.